Hello guys, so today I participated in weekly contest 394 and I solved all 4 questions from first to last. Now I will explain the question and I will explain the logics, and after that I will explain the answers of mine. So first question, count the number of special characters. So in this question you are given one word. So they are asking that you are given one word. It is string, which is of format like there will be lowercase words and uppercase also. So these are the two types which is present. So they are asking we need to return the count of character which are having both lower and upper characters in the string. So in first attempt I committed mistake because I thought if there will be multiple characters like same characters in multiple times like a, then I thought we need to calculate these things also, but it is not like that. We need to take only unique characters, like if it is 2 times, it is 1 time, like, or it is 2 times, then also we need to take only 1 time. So this was the logic question. And how I thought about this one, I just calculated the counts of lower values in one vector of 26, in which I just calculated the total count of smaller lowercase, and similarly I did for upper one. Now in this one, what I did, I just compared whether this value and this value is there. If the value is there, I will return 1. If both having some value, any value. If it is not, it will be 0 as usual. Then I proceeded similarly for next 25 characters, and that's the answer. Now I will explain my code. So declared word size small, large. Now here I am just calculating the smaller value. I declared small vector and large vector for the uppercase, lowercase. Just calculated that one, and just I compared if both of value, like the count of this one having value minimum among this one is greater than 0, means here is something 1, here is 2, or here is 1, here is 2, means there is at least one pair you can choose from this, anything among them. So if it is, we will return 1. It's not, then we will return 0. So this was the first question. Now we will go to the second question. Second question is some medium type or type 2 of first question. Count the special number of special characters. So in this question they are asking that they are given same word, which is string of lowercase and uppercase. Now they are saying that we need to return the count of those characters in which the uppercase character will come after all the occurrence of small character of that upper character. Like when a will of all the world will come in front of first a, we need to return that character, the first a, not last or anything, just first a. This first character which is coming after all the smaller characters of that character in the word. So this was the question. Now what I thought about logic. So in this question they are asking we want lower character, all lower character, all. So they are asking we need all lower character. So for that reason, what I thought, I just declared that small and large, in which in small vector I stored the indices of the lowercase characters, means maximum indices. Like I will update that indices for every character, like for a, which will be the max indices for the lower character. And in a, what I was storing, in large, what I am storing the smallest indices of the upper character for all respective 26, and similarly for 26. For all 26 I am just storing the indices 26 for both small lower and upper. Here I am storing highest indices, here I am showing lowest indices. Now after that I am just comparing whether this value is smaller than this value. If it is, then we will count +1, else we will count +0. So this was the logic how I code. I just declared the small and large, and then I just counted, just updated the last value, highest character indices in small, and similarly for large one I am just storing that I in min form. So firstly I declared n+1 for highest one and -1. In my first attempt I declared here 0, but that was my mistake. I thought it will be it's like I didn't find that thing corner case, so it should be -1. So I updated these values. Now when both values will not be equals to 0, then and only we will compare. If it is any value is not present, then there is no any point to check. So I'm just checking here, and if the small value, if this all the characters are in downward side and upper character in upward side, this one, then the answer will be okay. So we will check whether this one is okay, that indices of small I is smaller than the largest indices, and the largest indices will give minimum value. So this was for second question. Now we will go for the third question. So in this question they are asking minimum number of operations to satisfy conditions. So how many people solved? Almost 4,000 people solved this question. And in this question what you have given one grid like this way, the size will be like this way. So they are saying that if suppose if any value is x, then this in this grid the value of x should be equal to below and should not be equals to this value. So we need to make final grid by in which all the values will be like this format, like this y will not equals to this value will not equals to this value, but below value will be equals to as usual. From this from this one, how many you can update any grid by any non-negative value, that's your choice. So asking how many minimum number of operation needed to make it like the fulfilling the conditions. So this was the question. Now I will explain the logic. See, there are two observations which I observed during the contest. First observation is that if any value is x, then all the values of the column will be x, and if any value here is something y, then x will not equals to y, but all the column of second like y1 will be equals to y. Means in first row those value will be present, that will remain always below similar, there will be no any change in that values. So these are the two observation. Now how we will solve this question. So basically in this question there are multiple there are multiple numbers, like there are multiple possibilities. Actually they have given only numbers from 0 to 9, only given 0 to 9. So there will be only values from 0 to 9. Now in this question, like there are multiple possibilities. So what I thought, I will explain the logic behind it. I just calculated the how many values are from 0 to 9 counts are present in this column, in this column. So I stored one in 2D array. I stored that in first column how many values of 0 to 9 are present in one DP or one count vector, in which first is column, second is the character count, like 0 how many times, 1 how many times, like this way. So I got the values of this column this for this array, like first row, I just updated the values of below with respect to count. Now similarly I did for the all the rest of columns. Now see, when you get to know about this one, so now you need to decide which values you will keep here. That will give you the minimum operations. So at the end there are how many possibilities? Like here are 10 possibilities, 10 possibilities, 10, 10, 10, 10. So at the end you have this much possibilities. So it will go up to 10 raised to m, this much possibilities. So when you think about such things, that there are multiple possibilities and multiple ways to see, that time there are chances that you need to solve this question by dp. So this question is based on dp, that how you will solve this what to say, distribution. So in this one, what I did, I just calculated this value. Now here is 0 to 9 count I know, here is 0 to 9 count I know. So when I take this value, if I take 0, then what I will do, I will go next. But here I will not take 0, I will take any value from 1 to 9. If I take 2 here, then I will take here value from 0 to 1 and then 3 to 9. Similarly I will go for next one. But whenever I come at any point, then I will store that already pre-calculated value in dp, in which I will store the indices, correct indices, and the last value. I'll store when we come again and we will go there. So if it is already calculated, it will return that value. If it is not, it will go and we will go. So at the end the 10 raised to m solution will come into order of n. So order of m, suppose, or yeah. So we will get optimal solution by this way. Now I will explain the code. This was the logic. So in this question, firstly I just declared one count variable, 2D vector, in which I just counted every number from 0 to 9 for every column. Now I declared one dp, in which I am storing in 2D dp. I am just making column size equals to row size of dp, and I am keeping vector as 11 size, because in starting there is no any last character, so we are declaring -1. Now we will come here, and in this one, in solve function, I am just declaring last current indices, size of rows, size of column, and just going ahead. So why I am taking size of row? Because we know that total count of characters, numbers from first row to last row will equals to the total rows. So for that reason I am declaring I am sharing n also, and m is column, and just count and dp. In this one, if we go at the end, if we go up out of this bound, then there is no any point, so we will return 0. If it is already calculated, I am just declaring last plus 1, because we can't store -1 in dp, like in indices. So if we do +1 for every value, so here we did this one, last plus 1, return dp. Now we will check every possibility. We will check if it is not equals to last, then we will take that value. Like here, if we suppose we decided to keep 3 here, then what we will do, we know the total number of numbers present in this column is n. So we need to change the values which are not equals to 3. So it will be count of that column 3 minus. So total minus how many of 3 already present in this column. So we will need to change this one. So I am doing that thing. After that I am just moving forward I plus 1, and I am updating the last value with the current value j, and I am going down again and again forward, and I will get the answer. So this was for the third question. Now we will move for the last question. So in this question, they find edges in shortest path. They are saying there are graph like this way, like this way, like this way. So they are saying there are weighted graph, there will be value a, b, c, d. So they are saying you will go from 0 to n minus 1, like you can suppose 1 here, and you will go. So you will go from 0 to n minus 1. So the path following from 0 to n minus 1, the shortest path, in that shortest path there will be multiple shortest path, like the value of shortest path is 100. Then the summation of coming from 0 to last node from different path can give 100 as same value. So there are possibilities that 100 will come in different paths. So they are asking how many you need to return an answer in which the edges of shortest path will the edges of between this in between this shortest path will come. Like suppose this path is there, this path is coming in shortest path, this path is coming in shortest path, then they are saying that you need to return the boolean array in which the edges which are present in the shortest path will get to know about that this edge is present. Like we need to return one boolean is true if the edge is part of at least one shortest path. So they are saying this edge, if it is this edge is part of any shortest path from 0 to n minus 1, then we should return true, and we need to return that array. Like here they are returning true, false, false, and these are the size of edges. So this was the question. Now I will explain the logic. So let's think. Zero, 1, 4, 2, 3, 5. So what I thought, if you want to go to a from 0 to n minus 1 as the shortest path, you should know the value. How much value it is required to go from 0 to 5, means 0 to n minus 1. So firstly, from this one observation, we will get to know that we need to use Dijkstra or any algorithm which is suitable for finding all the values from one node to other, shortest distance from that node to all nodes. So here we will go to 5, but we need to also calculate the values still going for every node, because at the end we should know that how much distance we require to come to that point, not only up to n minus 1 but for all. So I used here Dijkstra for finding all the values from going from 0 to all the nodes and minimum distance we will get for every node. Now later what I thought, 0, 1. So suppose we are at this point, and the value of this point is 100. Suppose value of this point is 100. Now to coming at this point, from coming from this edge to this edge, like there will be some value at this point x, and this is the edge value. To come to this point, from this point, if difference between these two values comes to be y, it should be like you are coming from this way, means obviously this should be smaller than this value 100. So at the end, the difference between 100 minus x equals to y. If it is there, then this edge will come in one of the shortest path of all the shortest path. If you just think like the sum of this one is 90 till date from 0, and this one is 10, and coming to this point from other paths the sum is 100. Means if you come at this point 3 up to 90, and when you go for 5 by adding 10, it will comes to be again 100, but 90 is from 0 to 3. So at the end this edge will be come into a calculation. So from this we will observe that 1, 2, 4, 2, 3, 5. If you come at this point, you will check to coming to this point and this point. Like for these points, like you are coming, we are going from n minus 1 to 0 node. Suppose we are going backwards, not from this words, because already we calculated values from 0 to n minus 1. Now we are going from n minus 1 to 0 to see which path, which values are satisfying the conditions. So you will check if this value is fulfilling that condition of shortest path of suppose 90, and here is total 100, and this age is 10. Means if this condition that 5 minus 90, 5 minus 3 value will give the age value, age weight, then that age will come into our answer. So we will store that value, that this age is coming in our answer. Now this is like, for checking for this value, you will go only up to 3, 1, 4. Then you will go up to 4. Then you will go on 1. Then you will go on 3. Then you will see there is pattern that you are going by step. You are going by step. You firstly go on 5. Then you will check for 4, 1, 3. Then you will come on 2. Then you will come on 0. So you are checking by step. Through this you will get to know it is BFS type. So this is BFS, in which we are going by step wise. So in this one I am just checking whether if this node is fulfilling this condition of coming shortest path. If it is present, then we will push into our queue, and now we will remove this one values. Now we will go again, we will check similarly for other nodes from the current queue, like the values present in the queue. If it is there, we will move and we will add that edges. So this was the logic, and we will I stored this edges in map, and I will just run one for loop in which I will check whether that edge is present in our stored hashing table or map. If it is, maybe I will mark it true, otherwise I will mark it false. This was the logic, so I will explain in my code. So I declared one adjacently list in which I stored the values of vector in which pair of vectors in which age pointing towards the next node and the weight I stored here. Now I'm just declaring priority queue for Dijkstra. I'm just doing one DP in which I'm just storing the distance till a minimum distance till that node from 0. So I've just pushed for 0, there will be no any distance, there will be 0. Now I'm just pushed 0 0 in which I'm using Dijkstra. I'm verifying, I'm just calculating all the distances of all the nodes by this way. I just updated. Now I'm calculating queue in which I'm just using BFS, in which firstly I'm declared one map of pair, like there will be U, V and W. This is the map of my map, and I will count if it is present. If this age is fulfilling the condition, I will mark it as 1. So now here I am using simple BFS front. Then if the node is already visited, there is no any point to check again. So if it is visited, we will continue. If not, we will mark it 1 like visited, and we will go. Now I am just checking whether that condition, that node coming from this node to this node and the weight, if it is fulfilling that condition, like the distance from the 0 to 1, 1 to 3, and distance from 1 to 2, and the when go you are going from 2 to 3, the total distance will come in again 20, then this edge will be in the one of the shortest path of the graph from 0 to n minus 1. So I'm just verifying that condition. And for like when you use queue, that time what will happen, like this is undirected graph, so you need to check whether you are verifying with that value of the distance should be greater than the current node, like the distance should be greater than or smaller than, sorry, you are checking, you are going from backward, so you should check value should be smaller than 20, like smaller that value. So you will mark that value, and then you will push that node. Now I will check, I will take all edges, I will mark that false, and I'll traverse through all the edges. I'll check whether any of value is equals to 1, because there will be chances that in edges it is given 2 to 3, but in your actual it is 2 3 2, you are marked a 3 to 2, so you need to check this value. At the end it is undirected, so there is no any point, but along that you need to check whether weight is equal or not. Means like there is importance of weight in this also. So if it is any of this condition matches, I will mark it true and I will return the answer. So that's it for today. If you like my videos, please subscribe to the channel. It gives us motivation to solve the questions, and thank you very much. Do follow us on social media platforms like Instagram, Telegram. Thank you very much.